Today we are going to be factoring numbers and figuring out whether numbers are prime or not. And so let's talk about what a prime number is to start with. A prime number, here's what word prime right here, a prime number is just a number that is a whole number, but it has to be bigger than 1. So whole numbers are numbers like 0, 1, 2, 3, so they're integers that are positive, and they continue going on up. Well, prime numbers do not include 0 or 1, so we start at 2. And 2 happens to be the only even prime number. 3 would be the next, and the one after that would not be 4. 4 is not prime because we can only have 2 numbers that multiply to make it. The number and 1, so itself and 1, so 4 is not a prime number. Composite numbers are numbers that have more than one factor. So again, prime numbers have two factors, two numbers that make up the value, so 1 and itself. Where we have a composite number has more than 2 factors, so it's a whole number again, whole number or positive integer, whole number that has more than two factors. So what we have to look at when we're talking about factors is we have to understand some divisibility rules. And so here are the rules that I would end up memorizing. I would know the divisibility rule for 2. So if it's an even number, so that means it ends in an even number, so the number could be like, let's say 32. That ends in an even number, so we can divide that by 2. For 3, the divisibility rule is the sum of the digits is divisible by 3. So if I had the number 100 and let's go with 23, this is divisible by 3 because if I add the digits, 1 plus 2 plus 3, that equals 6. And I can divide 6, I can divide that sum by 6. Divisibility rule for 4 is that the last 2 digits are divisible by 4. So it really works well if it's a big number, like a 3-digit or larger. So let's say it was 2032. I know I could divide this by 4 because 4 goes into 32. For 5, you just look for numbers that end in 0 or 5, so that would be something like 35 or 70. Those are numbers that end in 5 or 0, then I know I can divide those by 5. For 10, it has to end in a 0. So if it just ends in 0, like 70, then we know you can divide by 10. And even bigger, you could even do 100. So at 100, it would have to end in 2 zeros, so it would have to be like 600. For 25, it has to end in either double zeros, 25, 50, or 75. So for instance, if I had the number 375, I know I could divide this by 5. And the way I would is, since it ends in 75, you can think of quarters. So $3.75. So 4 quarters equals $1. And so if I said this is $3.75, I would do 4 times 3, which would make 12. And then I'd add on 75 cents. Well, that's 3 quarters, so that would be 15. So I know that 25 goes into 375 15 times. So I'm going to use those concepts to figure out these next few problems. So we have 2 sets of directions tonight. It's either going to say to tell whether each number is prime or composite. Prime meaning that it's a whole number, like 2, 3, or 5 would be the next one. And it can only have 2 factors, 1 and itself. And so if I look at this, I use the divisibility rules. Can I divide it by 2? No. Can I divide it by 3? Yes. I can take 3 plus 3 equals 6. So I know that 3 goes into 33. So I would say that is a composite number. 41, prime or composite. Well, I look at my divisibility rules. It's not even, so it's not 2. 1 and 4 add to make 5, so I can't use that rule. The last 2 digits, nope, it's not even, so 4 is not going to go into it. And then 5 doesn't end in a 5 or 0, doesn't end in a 0, doesn't end in double zeros, 25, or anything else. So I would say this is a prime number. 52, this is an even number right here, so I know this is composite. And this one's an odd number, but let's check that rule for 3. So if I add the digits, 7 and 9, those add to make 16. So no, 3 is not going to go into that. I know 4 doesn't go into it because, again, in order for 4 to go into it, the last two digits need to 4 needs to go into the last two digits, but that also means that it has to be even. So 4 doesn't go into it. So I can't use that rule. Can't use 4. Doesn't end in a 5 or 0. Doesn't end in a 0. So I would say this one is prime. 121, I see that 1 plus 2 plus 1 ends up equaling 4, so I can't use that rule. Can't use 2, can't use 4. Well, there's one rule that I didn't use here, and that is 11. So 11 times 11 does equal 121. So this one is composite. So there are a few ones that will end up being like this, like 13 times 13 is going to equal 169, and that doesn't have any of these factors. But this is just a special case. So 83, let's take a look at the digits again, not even. And can I add the digits to equal a number that 3 goes into? Nope, that doesn't work. It's not even, so 4 is not going to go into it. 5 doesn't go into it because it ends in a 3. 10 doesn't go into it, so I would say this one is prime. 119, let's do that same thing. Let's add the digits, 1, 1, and 9. That makes 10 and 1 make 11, so that doesn't work. And let's try another one. We've got 2. No, 2 doesn't go into that. 4, no, 4 doesn't go into it. 5 doesn't. And so let's see if we've got anything else. 5 does not go into this. 10 does not go into 25, so then I would say the number is prime. So let's take a look at our next set of directions. It asks us to write the prime factorization. Prime factorization is when we write each number as a product of prime numbers. And so what that means is we need to come up with what the prime numbers are that multiply to make 57. So we have to use those divisibility rules. When I look at 57, it's not even. So I know that 2 doesn't go into it. So what I'm going to make is a factor tree, and I'm going to write down a factor of that. Well, I go to the next number, 3, and I see if 3 goes into 57. And I see that when I go ahead and add the digits 5 and 7, I see that makes 12, and 3 does go into 12. So I know 3 goes into this number. So now I'm going to actually have to do some division. 3 into 57. So 3 goes into 5 one time, and there's 2 left over, so we bring down the 7. 3 goes into 27 9 times, so it makes 19. So 3 and 19 make 57, and those are prime numbers. And so that is our prime factorization. Well, the next one's going to take a little bit more time because there's more factors that make up 56. See, we have 7 times 8 makes 56. 7's a prime number, but 8 is not. It's a composite. So we need to continue breaking that down. So I broke the 8 down to 4 times 2. But notice I brought that 7 down with the number so I don't forget about it. Well, 4 needs to be broken down as well. So I have 2 times 2 times 2. And then again, I'm going to bring down the 7. So here's the prime factorization. However, we're going to use exponents to represent it. So since there are 3 2's, I'm going to write that as 2 to the 3rd power times by 7. And that would be the prime factorization I'm looking for. Well, taking a look at the next one, I see it's even, so I know 2 goes into it. But I'm looking at 68, and I'm pretty sure that 68 is going to go into there, because if I take 4 away from 68, that makes 64. I know 8 times 8 makes 64, and I know 4 goes into 8, so I'm pretty sure 4 goes into that number. So I'm going to try dividing it by 4. It'll just make the factoring go faster. And so I do the division. 4 goes into 16 4 times. 4 goes into 8 2 times. So 4 times 42 makes 168. So I'm going to break those numbers down. 2 times 2 makes 4. And I break the 42 down, and that's going to be 6 times 7. So now I still need to bring this 6 and break that down. So I'll bring down these 2's here. So I have 2 and 2. So I just brought those down, left some room for the 6, which is 2 and 3. And then I'll bring down this 7 as well. So there it is. 3 2's, so 2 to the 3rd power, and then times by 3, and then times by 7. And that's the prime factorization. Well, looking at our next problem, we've got 725. I could use this rule with 25s. It ends in a 25. So I'm going to go ahead and take 25 and divide it. Now think of quarters as you do this. So 725 pennies. That's what I'm thinking of there. How many quarters does that make? Well, $7, that makes 4 times 7 makes 28. And so I know I have 28 at least, plus one more quarter makes 29. So let's see if I can get that same answer using long division here. See, if I do 2 there, that makes 50, and then I have to subtract, and that leaves me with 22, bring down the 5, and then 25 into 225. Let's see if it does go 9 times. It makes 45, that makes 18 plus 4, yep, makes 22. So I got the same answer doing it the other way. So again, 7 times 4 made 28, plus 1 quarter made 29. So that breaks it down pretty quick. Now I just need to break the 25 down to 5 times 5 times 29. And then go ahead and write that in the exponential form. 5 squared times by 29. 1,040. Well, I see it ends in a 0, so let's go ahead and take out a 10, and that makes it 10 times 104. Now look at the last 2 digits, 0, 4. Well, 4 goes into that, so let's divide that by 4. And let's break down the 10 as well. So 5 times 2, and bring down the 4. Now do 4 into 104. So 4 goes into 10. We have 2 times, with 2 left over. 4 goes into 24 6 times. So it's a 4 times by 26. So let's break down some numbers a little bit more. So bring down the 5, bring down the 2, and 4 is 2 times 2. And then 26 is 2, because it's an even number, and you divide 2 into 26, goes 13 times. So let's count up our 2's. We got 1, 2, 3, 4 of them. So 2 to the 4th times by 5 times by 13. There is our answer. Well, looking at our last one here, we've got double zeros here, so I could divide by 25, but I see a bigger number. 100. 100 goes into it. Remember I said up here, 100 is any number that ends in double zeros. So that would be a little faster there. 100 times 25 makes that number. So let's break this down. This would be 25 times by 4 makes 100. And 25 and 25, well, 25 would be 5 times 5. So we just break down the 5s, or the 25s a little bit more. 25 would be 5 times 5 again. 4 would be 2 times 2, and then we'll just bring down these other 2 5s. And so let's count them up. We got 2 2's, and we have 4 5's being multiplied together. So those are the answers to those problems. Well, good luck on tonight's homework.